Explosions are usually seen as pure destruction, fire, chaos, and loss. But what if those same explosions are quietly saving lives? In a single controlled instant, science uses extreme energy to create artificial bones, spacecraft armor, and even diamonds. By mastering destruction, scientists learned how to create materials that shape our modern world. Once you understand this, you'll never look at explosions the same way again. At first glance, explosions seem like symbols of destruction. They tear things apart, release uncontrollable energy, and leave chaos behind. For most of human history, explosions were feared, avoided, or used only as weapons. But science did something unexpected. It learned how to tame explosions, slow them down, guide them, and turn their raw power into tools of creation. Today, controlled explosions help build materials that save lives, protect astronauts, power industries, and shape the modern world in ways few people ever see. This is the story of how humanity learned to use the most violent forces in nature to quietly create some of the most important materials on Earth. To understand this, we need to understand what an explosion really is. An explosion is not just a loud bang. It is energy released faster than the surrounding environment can absorb it. In a fraction of a second, pressure, heat, and shock waves race outward. Inside that moment, temperatures can exceed those on the surface of the sun, and pressures can rival the depths of planets. For materials scientists, this brief instant is a unique laboratory. Conditions that would normally require massive machines or years of slow processing can be achieved in microseconds. One of the earliest ways science used explosions for creation was in metal shaping. Traditional metal forging relies on slow, steady pressure. But some metals are too hard, too thick, or too complex to shape that way. Engineers discovered that by detonating explosives near metal plates, they could force metal into molds with incredible precision. This process, known as explosive forming, allows metals to be shaped without cracking, even when they are extremely strong. Aircraft panels, spacecraft components, and high-performance industrial parts are often made using this method. The explosion lasts a blink of an eye, but the result is a perfectly shaped component that may travel through the sky or into space. Explosions also allow scientists to bond metals together in ways that normal welding cannot. This technique is called explosive welding. Two different metals, sometimes ones that cannot be joined by heat alone, are placed together. An explosive charge drives one metal into the other at enormous speed. At the moment of impact, the surfaces behave almost like fluids. They mix at the atomic level without melting. The result is a bond stronger than traditional welding, free from cracks and weaknesses. These bonded metals are used in chemical plants, power stations, and medical equipment, where strength and reliability are critical. Perhaps one of the most life-changing uses of explosions lies in the creation of advanced materials for medicine. Artificial joints, surgical tools, and implants often rely on materials that must be both incredibly strong and biocompatible. Explosive compaction allows powdered metals and ceramics to be compressed instantly into solid forms. The shock wave forces particles together so tightly that they fuse without the need for extreme heat. This preserves delicate structures and creates materials with unique properties. Hip replacements, bone plates, and dental implants benefit from materials born in controlled blasts. Explosions have also played a key role in creating synthetic diamonds. Natural diamonds take millions of years to form deep within the earth under immense pressure and heat. Scientists found that by detonating explosives in carefully designed chambers, they could briefly recreate those conditions. Carbon is exposed to massive pressure in an instant, forcing it into a diamond structure before it has time to fall apart. These synthetic diamonds are not just gemstones. They are used in cutting tools, medical devices, electronics, and even quantum technology. A violent explosion creates one of the hardest and most useful materials known to science. In the world of defense and space exploration, explosions are used to protect rather than destroy. Explosive reactive armor, for example, is designed to counter incoming threats. When struck, the armor detonates outward, disrupting the force of the impact and protecting what lies beneath. The materials used in this armor are carefully engineered through explosive testing and formation. The goal is not destruction, but survival. Spacecraft materials face extreme challenges. They must withstand intense heat, radiation, and sudden impacts from micrometeoroids traveling faster than bullets. Scientists use explosive testing to simulate these conditions on Earth. By firing explosive-driven shock waves at materials, they can see how metals, ceramics, and composites behave under stress. This data helps engineers design spacecraft hulls, heat shields, and protective layers that keep astronauts safe millions of kilometers from home. Explosions have even helped shape modern electronics. Shock waves can change the internal structure of materials, altering how electricity flows through them. In some experiments, scientists use controlled detonations to create new phases of matter, arrangements of atoms that do not exist naturally. These materials can have unusual electrical, magnetic, or optical properties. They may one day lead to faster computers, better batteries, or entirely new technologies. Another surprising area is environmental science. Explosions are used to create special filters and absorbent materials that capture pollutants. Shock synthesis can produce porous structures with enormous surface area, perfect for trapping harmful chemicals. These materials are used in water purification, air filters, and industrial cleanup systems. Once again, a force associated with destruction becomes a tool for preservation. Even food science has felt the impact of controlled explosions. High-pressure shock waves can alter the structure of food materials, improving texture, preservation, and safety without relying on chemicals. While these are not traditional explosions, the science behind them comes from the same understanding of rapid energy release and pressure manipulation. What makes all of this possible is control. Modern science does not unleash explosions blindly. Every detonation is calculated, measured, and designed. Sensors capture data in millionths of a second. Computer simulations predict how shock waves will move through materials. The explosion itself may last only an instant, but it is the result of years of research and planning. There is something deeply symbolic about this. Humanity took one of nature's most violent forces and learned to listen to it, measure it, and guide it. Instead of fear, there is understanding. Instead of chaos, there is precision. The future of explosion-based science is even more astonishing. Researchers are exploring ways to use laser-driven microexplosions to create materials atom by atom. Others are studying how shock waves can trigger chemical reactions that are otherwise impossible. There is even research into using controlled explosive energy to recycle materials more efficiently, breaking down complex waste into reusable components. When you look at a medical implant, a spacecraft panel, a cutting tool, or a clean water filter, it is unlikely you think of explosions. Yet hidden in their creation is a moment of intense energy, a split second where matter was pushed to its limits and reshaped into something new. Explosions remind us that creation and destruction are not opposites. They are two sides of the same force. In the hands of science, even the most violent energy can become a quiet architect of progress. And perhaps that is the most powerful lesson of all. The future is not built by avoiding powerful forces, but by understanding them deeply enough to turn them toward life-changing purpose.